system, if you see this kind of phase trajectory, this plane is called phase plane. Phase plane or state plane. Again, it is the same qualitative analysis technique. Okay, we are checking here this trajectory. This is not x versus t. This is x dot versus x. That means rate of change versus the original variable. Okay, x dot versus here also x2 versus x1, where that is x2 is equals to x1 dot. And that is also the reason for the restriction why we can't apply this technique to third order or even higher order systems. Okay. Now you can see that is this phase trajectory, or like simply like this locus. That is, this is a locus of like simply a graph plotting technique where you have the system, you see the response in MATLAB from the data array. That is, you just make a table, that is x dot at different time, you plot all the points x dot versus x, then you will be getting the trajectory. If it is like that, then it is asymptotically stable. Okay, but suppose if it is something like at this moment I am not taking that term limit cycle, but suppose if the trajectory that we, because at this moment I am not introducing that terminology, but if it is something like that, that is after reaching some neighborhood of the origin, the amplitude of the oscillation is not further decreasing, then it would be a stable case. That means the the trajectories will remain magnitude bounded, but it is not asymptotically stable. In this case, this is asymptotically stable, okay, but this is not asymptotically stable but stable. Everything is qualitative analysis. Why qualitative? Because we are not finding the solution of the differential equation, right? From the graph plotting or from these auxiliary techniques, we are trying to understand the behavior of the system, right? Up to this much is fine for everybody, but my original question was, that is, if this is the situation, why can't we say that is the stability of the nonlinear of one nonlinear system as a whole? That is the question, right? See, this is now the equilibrium point. What did I say? That is, equilibrium point means it is a